Today we are going to start with a quick revision about moments and cover the topic tilting. Now, as you see, we have an example here that I am going to solve in a minute. But before that, I need to do a quick revision. What is moment? It is force times the distance, and the meaning is turning effect of a force, and needs a pivot, a direction L, and a force to apply. Either turns in the anti-clockwise direction, or if we apply a force in that direction, the object is going to turn, the rod or the plank is going to, or the beam is going to turn in the clockwise direction. And we have a very important word here, which is equilibrium. And to satisfy the equilibrium conditions, we have two rules. Either both must be satisfied. Sum of forces must be zero, and anti-clockwise moments must be equal to clockwise moments. And Umut Hoca's rules say that take moments with respect to the leftmost point. Let's solve that example, and by using all this knowledge from the revision that I wrote down, then I'm going to carry on with tilting. Let's have a solution of example. Let's have a quick sketch. We have a rod AB here, a beam AB here, and it is uniform. And what is the meaning of uniform? If beam or rod is uniform, means center of mass is at the midpoint. So we have beam AB here, its mass is 20 kilograms, so its weight is at the midpoint, pointing downwards, and weight is 20 G. This is point A, this is point B. It is held in equilibrium by two wires at points K and L. K is here, we have tension K there, L is there, tension L there, and a painter P is at point P on the beam, which is somewhere here. The painter. And AK is 0.5. From A to P it is 3 meters, and from A to L it is 5 meters. Remember, the distances are very important, and we have an 85 G here pointing downwards for the weight of the painter P. And the question says that find the tensions here, Tk, tension at point K on the wire K, and tension of the wire which is at point L. This is a quick sketch for the question. Now let's have the forces and the distances. This is tension K, 0.5 meters. We have tension L here, and its distance from A is 5 meters. We have 20G there, which is 4 meters because it is at the midpoint, and AB is 8 meters, so the midpoint is at 4 meters. And we have the weight of the painter, which is 85G, and it is 3 meters from point A. This is P, the weight of the painter, 85G. Let's apply the first rule. Let's apply the first rule. First rule says sum of forces must be 0. We have two forces pointing up, Tk and Tl, and two forces pointing downwards. So, and their sum is equal to 0. So Tk plus Tl is equal to 105 G. This is first condition there. And for second condition, we have to calculate the anti-clockwise and clockwise moments. Anti-clockwise moments must be equal to clockwise moments, and we have two forces that tries to turn the beam in anti-clockwise direction, pointing up, and the direction for Tk is the length of Tk from A is 0.5, and we have to state that we are going to take the moments about point A. So, the distance of Tk is 0.5. The distance of L is 5. The distance, these are the two forces pointing downwards which tries to turn the beam AB in the clockwise direction, and the distance of 85G from A is 3 meters. And the distance of 20G is 4 meters. So we have 0.5 Tk plus 5 Tl is equal to 335 G. So we have two equations here. Tk plus Tl is equal to 105 G, 0.5 Tk plus 5 Tl is equal to 335 G. So let's solve these two simultaneous equations to find the value for Tk and Tl. I am going to multiply that one by -2. So Tk plus Tl is equal to 105G minus Tk minus 10Tl is equal to minus 670G. So when we add these, Tk and minus Tk cancel each other. Minus 9Tl tension at point L is equal to minus 565G. So TL is equal to 565G over 9, which is, by using the calculator, it is 615.2, and we know that Tk plus Tl is equal to 105G. Tl is 615.2, 105G, so Tk is equal to 105G minus 615.2. Remember, G is always 9.8 in M1, so Tk is 105 times 9.8 minus 615.2, and the answer is 413.8 newtons. These are all in newtons because they are forces. This is how we solve a moment question. Yes, I am going to send the board to you, take a picture and send it to you via Messenger and WhatsApp, and if you have any questions, just ask. Yes. So you don't have any questions, so I am going to carry on with tilting. I am going to carry on with tilting. Tilting. Tilting is a condition which say that we have two pivots here, A and B. If that rod is tilting about B, means it is not touching to point A, but still at equilibrium, which means the normal reaction force at A is 0. If it is tilting about B, means it is not touching to point A anymore, have no connection with point A, but still at equilibrium, and we don't have any normal reaction force at point A. Or it is tilting about K, means tension at L is equal to 0, but still in equilibrium. Still in equilibrium. Let's remember our last example. A, B was the rod of length 8 meters. Mass of AB is 20 kilograms. We have a wire here. T, we have tension T on the TK on the wire at K. We have another wire here at point L, and we call it tension L. The mass was, the weight is 20 G. This was 0.5 meters, and if I remember correctly, this was the distance from A to L was 5 meters. Now let's change the position of the painter and put him somewhere here. With a mass of, was it 80 or 85? Say that it was 85 kilograms. Painter P mass is 85 G, and say that the beam AB is tilting about point L. Find the distance of painter P from point A. What is the distance of painter P from point A? And be careful with the statement here. It says it is tilting about point L. Means, let's start to solve the question. Means, again, let's try that one. Tilting about point L means TK is equal to 0. If the beam tilts from point L, means we have only one tension, which is is at point L, and it means we lost the tension on wire which is at the point K. That means no tension on point K. So let's redraw the graph. Here we have only tension at L. We have the painter here, and we don't know the distance of the painter from point A, but we know its weight, it is 85 G. We know the position of the center of mass of the beam, it is 4 meters from point A because it is at the midpoint. Why it is at the midpoint? Because if we remember from the previous example, it is a uniform one. AB is 8 and it is uniform, means its weight is at the midpoint, and we don't know the distance of P from A, but we know the distance of tension of TL from point A. The distance of point L from A is 5 meters. So we know all the distances. We know that our question is to find the distance x, which is the distance of P from A. So let's apply our rules. And our rules say that F net is going to be 0. And we have only one force pointing upwards, that is TL. And we have two forces, weight of the beam and weight of the painter P, pointing downwards. And pointing downwards means they are negative, and the sum is 0 because the system is in equilibrium. TL is equal to 105 G. Now, what is the second rule to be in equilibrium? Anti-clockwise moments must be equal to clockwise moments. And we are going to take our moment from point A. And how do we calculate the anti-clockwise moments? We have only TL pointing up, trying to turn the beam AB in anti-clockwise direction. What is its distance from A? 5. What is the force? The tension TL. What are the clockwise forces? The weight of the beam 20 G tries to turn the beam in clockwise direction. What is the distance from A to the midpoint? It is 4 meters. So 4 times the force. They are 4 times 20 G. And we have another force, weight of the painter, which tries to turn the beam in clockwise direction, and its distance from A to B is unknown. We called it X. The distance times the force, which is 85 G. Now we have only one unknown here. It is X. So let's substitute the value of TL here, which is 105 G. 5 times 105 G is equal to 80 G plus X times 85 G. Cancel all G's. We have 525 there is equal to 5 times 105 is 525. We have 8 there, 80 there, and 85X there. When we subtract 580 from 525, it is 445 is equal to 85X. So X is equal to 445 over 85, which is 5 5.24 meters. That's, so as you see, tilting makes the question a little bit easier. But we have to remember the meaning of tilting. If it tilts about point L, go to the other point and remove the tension or remove the normal reaction force. That's the only thing you have to do when you see the word tilting. So today we revised moments and we covered tilting. Now I am going to give you some homeworks from your M1 book, International M1 book, and tomorrow I am going to solve those questions. And homework questions are question page 142, question 4. Page 143, question 8. And page 144, question 9. Tomorrow I am going to solve these 3 questions for you, and hopefully if we have time I am going to solve a couple more. Okay, see you tomorrow. We are going to meet tomorrow at 1 o'clock, hopefully, if we don't have any connection problem. And I am going to solve, these are from your mechanics M1 book. Tomorrow I am going to solve them, and I am going to finish M1. That means we are going to finish moments tomorrow. That means we are going to finish M1. Then I am going to solve some exercise questions to you during the week. Now I am going to take pictures of the board, send them to you, and if you have questions you may ask. I am waiting for questions if you have any. Yes, see you tomorrow.